Hello, coders. Good evening. It is episode 119 of the How to Code Well podcast. Sorry, I am off. There we go. It's episode 119 of the How to Code Well podcast. As you can probably tell, this is live. It is the 14th of October 2021, and today I would like to talk about some branch good practices in Git. So Git being the source control, and I have 10 good practices to use when you're dealing with branching and merging and all that good stuff. We'll get to that very soon. Before we do, let's just do a little bit of housekeeping. So big apologies for not being able to stream in the last few weeks. I haven't been on Twitch or YouTube or here. Unfortunately, my cat passed away, so I took a bit of time off. One of my cats passed away to deal with that, and but we're back. We're back, and we've got a really good show today. I think a really good set of info for branching and Gitness. Gitness, that is a word now. Also, I want to just mention that. There's a couple of two little news article thingies I want to mention. One being that there's a bit of PHP news. So PHP, the SWOL extension for PHP, it has been forked. So if anybody's using SWOL in I think that's how you pronounce it, SWOOLE, the PHP extension has been forked due to some ongoing security concerns. The current version of SWOL actually downloads a compressed file from the business site of SWOL, which, as you can probably imagine, isn't good news, isn't great. There's a ton of security concerns there. It would seem that it's a gzip file, and this gzip file is, like I said, downloaded from the business site of SWOL, and it downloads to your application and runs. This is according to a screenshot that was given on the PHP mailing list. Apparently, many attempts were made to raise this concern with the current maintainer of SWOL, but nothing happened. And therefore, the PHP community, quite rightly so, decided to fork it. And they've now created their own sort of version of SWOL called OpenSwell, which is the alternative. So if anyone is using SWOL, and I must say that I actually don't know anyone who does, but I am aware that of its existence. I actually went to see a talk at a conference about SWOL and the interesting things you can do with SWOL with PHP. But if anybody is using it, then please do consider upgrading. I mean, this is quite a bad thing in terms of security. I mean, even if it was done without any kind of malicious attempt, sort of thought. Having the ability to download a remote file that you're unaware of due to a PHP extension is not good. I mean, imagine, if you will, that site was to be hacked and the hacker was aware of this vulnerability. It would expose, it would damage a load of PHP sites, let's just put it like that. And the thing is, I mentioned that I've never used SWOL before, and I don't know of anybody who does in terms of projects. But that doesn't mean that it's not enabled. So I am aware of projects that have a load of extensions enabled and they don't use them, but it does they do run. They do run. Yeah. So SWOL, it's an extension for PHP, so just be cautious. I've put a link in the show notes in the description about this for anybody to read up on. Basically, the takeaway there is to upgrade your things. Get off of PHP 7 as quickly as you can, and if you are using SWOL and you know you're using SWOL, then please do use this OpenSwell thing. But it's hats off to the PHP community for jumping on this and getting this sorted so quickly. In my opinion, I think the PHP community need to have a round of applause. Taking on an extension, a whole extension, is actually quite a massive piece. Well, taking on anybody's piece of code is a massive challenge. So it's a massive commitment, right? This is a big commitment. So there we go. The next piece of news is regarding the Apple event that's happening on the 18th. The 18th of this month, so in a few weeks' time. This is quite exciting, actually. So, as you may have known, I am thinking about upgrading my MacBook, which is like the 2019 version of the MacBook Pro. It's a 16-inch, and it's only got like 16 gigs of RAM. It's incredibly slow. In terms of like when you get it to the very top of the peak performance. I do a lot of stuff with Elasticsearch. I do a lot of stuff with loads of Docker containers. It does start to crawl, especially when you've got, Chrome tabs open. I've fallen into that trap of using the Chrome grouping mechanism that they now have introduced. So now I have even more tabs that are open. And they do all sorts of things like, go drilling into Chrome query, Elasticsearch queries, and have content management systems open and other pages open and doing all sorts of interesting stuff. And then, of course, you've got the IDE open. Then you've got the terminal open. And I'm probably running at least 2 or 3 scripts at any one time. It does start to crumble. So I am in the market of upgrading. And I'm got half a finger on the trigger of getting a Linux machine, probably if I can swallow the import tax, a System 76 box laptop. However, I do want to hold out for this Apple event. Essentially, if they have if it's limited to 32 gigs of RAM, then I will just disregard whatever the speed of the CPU is. For me, it needs to have at least 64 gigs. 16 is just too small. 32, I just think it's going to be too small in a few years' time, and I want a machine that's going to last for a while. So that's what I'm holding out for, to basically see what the price is for the 64 gigabyte RAM job of the M1X MacBook Pro. Will I? Won't I? I don't know. I might just go and buy a Linux box and use that, but. Anyway, I'll keep you updated as to which one I go for. Okay, so let's get back into the topic of the main show. Thank you ever so much for joining, Bernard and Akas, Dave. Thank you very much for joining. I appreciate that. So Git. Git is a source control application, I guess, where you can obviously store your code, and that you can use like pipelines to control when certain things happen to your application. Certain points, whether it gets deployed, when things get tested, get built, that kind of stuff. And what I've done is, because recently I've been dealing with a load of issues with like conflicts in code and sharing code amongst the team and stuff like that. So I decided to just write out. I've actually got 11 points here, but I'll try and condense it down to 10. 10 points for good practice when doing branching and merging. Before Git, you had SVN. And then before that, you had I was using some other random thing from Microsoft back in the day. So Git changed the game when it all sort of decentralized. That was really an interesting learning curve to learn how to use source control using Git and using a decentralized source versioning tool. And I guess new developers don't need to worry about centralized source control, so that's cool. So I'll just assume that everybody here is aware of Git. That's kind of like where the audience, I'm going to sit them. So everybody is aware of Git, so I don't have to go through the history of what Git is and all that jazz. the interesting thing I find is how you configure Git to work with your team members, and how it can scale from one like one team member to 10 team members or 20, because there are certain practices that you put in place when your team starts to grow. And those practices that you put in place when your team's at that scale don't make a lot of sense when you've only got one member of your team. So this is like the difference of, let's say I've got a side project, so it's only me working on this thing, or I'm actually working on a project for a client and I've got 10 other developers working on the same code base. A bit different. It's a bit different. So what we're going to do today is talk about when you're actually working in a team of people. So you're working in a team of people, let's give it an arbitrary number, let's say 5. So 5 developers, they have all access to your source control, which means that they can commit changes to your branches, and you can commit changes to their branches, and you are all working on sort of one single project. And the first thing that I would suggest, my first tip, is to ensure that your pipeline is constantly working. Constantly working. So when I say pipeline, what I mean is that you've got your continual integration, so your CI. So this is where you're continually integrating code into your source control, and the pipeline goes from various different stages that you set up, from perhaps code auditing to merging to testing, or in a different order perhaps, and then building, and then deployment if you're doing CD. So what you want to make sure is that anything that gets pushed into your pipeline goes from one end to the other end incredibly smoothly. And if there is ever a point where your pipeline just gets blocked, then it really should become the first priority to unblock that over other priorities of the team. Because this is the thing, let's say you've got 5 developers, you only have one pipeline, right? So you only have one pipeline, one source control that your team members can push to. And so if one member by accident, because this is never done on purpose, by accident, pushes something to that pipeline which breaks the pipeline, then you're preventing the other 4 developers from actually using that pipeline, and so you immediately get a blockage. So the first thing to do is to ensure your pipeline works, and I do this using auditing tools. So I'm a PHP developer, for instance, so that would include things like PHP Stan for static analysis, PHP CS, linting, PHP Unit for testing, all of those things, and more, PHP MD for mess detection, yada, yada, yada. There's a load of different auditing testing tools that you can do that checks your code base, and also things like code sniffing, so to make sure you're following the conventions that are laid out to the team, your common conventions, coding conventions. And if any of those fail, then you don't want the code blocking the pipeline. So you want to run those before you actually decide to push your code into the pipeline. And then you want the pipeline to run them as well, to ensure that nothing actually gets into the pipeline that shouldn't get into the pipeline. But and it's like a safety net, if you will. The thing is that as soon as something gets broken, because it will, something will get pushed in. Someone will forget to run the code auditing tools, or perhaps the code auditing tools are updated and the other person who is doing the push hasn't updated the code auditing tools and therefore fails when they do the merge. When that happens, and it will, jump on it. Jump on that, because like I said, you are blocking the other developers from actually doing any of their work, pushing any of the thing. So the first one is to run code audits before merging into the workflow. And I guess you could also part that up with a second one, which is if there's ever a problem with the pipeline, down tools, fix the pipeline. Fix that. You never really want to be that guy that screws the pipeline up, but that happens. I've done it before, plenty of times. But you just want to address it as fast as possible. Okay, the second one is more about the code. Okay, so the second tip is to when you're writing code that requires some configuration. So, I mean, this could even be feature flags, or this could be some config that you put into, if you're building something in Symfony, it could be like your services.yaml, it could be an environment variable, it could be config to your Docker containers or whatnot. If you can, try and put that configuration, code as configuration, separate to the actual feature that you're building. Sounds a bit weird, right? So you end up with basically 2 pull requests. And you want to make sure that the code that you write can also can identify the fact that the config doesn't exist and therefore doesn't break it. It's not relying on that config to be there. So always check whether or not the configuration, if it's in services, gets injected into your dependencies or whatnot, and if it isn't, deal with that. The reason why I think that it's best to separate your configuration from code in terms of branching is because configuration, in my opinion, is more about setup. You're setting it up for your feature to work, and it's often easier when you're working in a team where you've got different people working on different features, all for the same project, to have different branches for configuration. If person A has different configuration to person B, and you both need to merge both of your configurations into the pipeline, it's best to have that separate from the code, because you'll end up screwing around with merge conflicts and stuff. Basically, you're trying to whittle down the problem surface, if you will, to just the very bare minimum, and you can then quickly identify code issues. This happens more frequently than not, actually, when 2 people are working on the same configuration file, and perhaps one person puts some configuration below the other configuration, or someone changes some existing configuration. It can get a little bit tricky when that configuration is embedded in the pull request of the feature. So it's a little bit easier if that's broken down into 2 pull requests. In fact, I've worked in places where we have 2 or 3 pull requests for a feature. It's you can break it down. You can break it down. It doesn't have to be one siloed piece of work. You can break it down into smaller chunks. We'll get on to breaking things down a little bit more when we start talking about code maintenance and stuff like that. But there's also things where you've got encryption. So when you're committing an encrypted file, if you've got 2 people trying to commit an encrypted file, that's a pain in the ass, because you've got 2 encrypted files. So whenever that happens, you want to have communication, right? You want to talk to the other person and say, look, what's going on here? We kind of need to have one single thing to work on. And like I said, that gets really messy when that's sort of embedded in the code. So in your feature pull request, you want to make sure that your feature doesn't balk the system if the configuration doesn't exist. That's basically what I'm trying to say there. All right. So moving on to number 3 is around merging. Merging and conflicts. Basically, you want to treat any code conflict, and you'll get them with kitty gloves, right? Really be properly careful with code conflicts, because it basically means that your code is conflicting with another piece of code that someone else has written, and it can get quite messy. If you screw it up, then you're not only going to screw up your code, but you're going to screw up the other person's feature as well. So you've got to be very, very cautious. This is where you've got to become a team player. You can't just go, okay, well, I'll just accept mine. I won't be accepting yours. I'll be accepting my changes because, I want to finish early today. And I'll screw yours up because, that's the kind of guy I am. Don't be like that. Don't be like that. You want to use I use PHP Storm, and there is a fantastic feature for resolving conflicts in PHP Storm where you have three sort of split views. You have the left view, you have the right view, and then you have the main view. So basically 3 columns. It's great. I've got a nice big monitor here that I can use to have those 3 columns. Basically, what I'm seeing here is my code, the code that I'm merging to, and then the middle code, which is the merge. And PHP Storm, it's a diff. Essentially, it's a diff. It's a graphical diff. The graphical diff has arrows that point from left into the middle and right into the middle. So this is saying that this piece of code needs to go here, this piece of code needs to go there, and so on and so forth. And you click on the arrow and you move the code across. There's also a cross. If you click on the cross, then it ignores that entry. So that's really, really useful. So you can see what you're trying to achieve. You're also seeing what you have to change, and then you're seeing the output of that change, which is really, really helpful. So use that. Now, I'm a massive fan of the command line, right? I use the command line all the time. In fact, the command line iTerm is probably the most used thing apart from apart from the actual code editor itself. But anytime I'm in the code, anytime I'm doing something on the terminal, I will go to the terminal iTerm. I won't use the terminal in PHP Storm just because I'm more comfortable in there. However, when it comes to conflicts, because I know how important it is to get these things right, I like to see my code. I like to see the code I'm merging to, and then I like to see the output of that. So I do rely on graphical user interfaces whenever I need to, and that's fine. Number 4 is to communicate and talk through conflicts with other developers. So let's say, for instance, you're merging something in, and you know that someone else has done some work around this area, and you can actually use the git blame or git annotation to work out who wrote what line of code when. If you are struggling through a conflict, then get in touch with the developer and say, look, do you have 5 minutes just to share my screen and I can show you what I'm doing? Because I don't want to screw your stuff up. And that's really important. Again, this goes back to being a team player. You don't want to be screwing anybody else's code up. But at the same time, you want to make sure that the code that you do works. So having multiple eyes on it also helps with pull requests as well. And that's another point that I'll make later on about pull requests. Number 5 is a bit of a controversial one, and this is don't squash commits. I like my history. In fact, there's been a few projects where I've left. I'm a contractor, so I will join a project, I'll go to another project, and then sometimes, if I'm lucky enough, I'll go back to the other project, the previous project that I was on. And obviously, as you're probably aware, when you switch projects like this, it takes you a while to remember where you were last time. So as a contractor, it's like a 3-month or a 6-month or even a year sort of rolling contract type thing. It takes a while to come back to where you were when you last left the project. Going through your history is really helpful, because then you can get back into the mindset of your previous self really, really quickly. And also you can see how the project has evolved through the history of Git commits. That's why I'm not a massive fan of squashing them. History's fine, man. I mean, leave it. Don't there's no... I understand if you're using like an open source project, it can get annoying when you've got huge history of stuff. But when you've actually got a small team of people working on a single project, it's nice to have that history. It's nice to read the thoughts of the other developers. Okay, so where are we now? Number 5. Okay. Number 5 is, now I'm not going to talk about the differences between Git Flow and the traditional ways of using Git and all that jazz. You know, what's the difference between staging versus develop, or hotfix branches versus release branches. I'm not going to worry about that. In my opinion, don't use Git Flow. That's just my opinion. And if you want to know why, I'll probably do another video on why I think that's a bad way to go. I used to use Git Flow and it just drove me nuts. Keep it nice and simple. So whatever you use, you'll always have a stable branch. And I remember back in the SVN days, we had trunk. Well, in Git, you'll have something like main or master. This is the stable branch. This is the branch that works. Then you'll have another branch which you merge pull requests into that can be tested. So maybe if you've got a QA team or like just a team of testers, they can test on that branch, and when the features in that branch are ready, they can then get merged into the main branch, and then that gets deployed. I mean that's as complicated as it really needs to be. In my opinion, I think if you overcomplicate that by having release branches and stuff, unless you're working in a team of 20 plus developers, then having a release branches are just extra complexity. I made a point earlier about, if you're just your single developer, then there's a lot of these tips that don't matter to you because it's just you. But if you're working in a team of say 5 to 10, then these definitely do matter. But if you're working in teams bigger than this, then there are other benefits and good practices that they would need more than the group of 10. Okay, so the tip here is to, when you've got your branches set up, so you've got say main, and then you've got like develop or staging, what you want to do is make sure that you're regularly moving code from main back to your feature branches. So in fact, actually, I mentioned that you've got 2 branches there. In fact, you've got 3. So you've got your main branch, you've got your staging branch, and then you've got your feature branch. Your feature branch is your branch that you're doing code on, you're working on. The main branch, like I said, is stable. Nobody commits directly to that unless it's a merge. Then you've got staging. Now, staging is the in-between branch between your feature branch and the stable branch. If you're working in a team of, say, 5 or 10 devs, maybe, multiple developers will be working on, every developer will be working on perhaps their own feature, right? So they'll have their own feature branch. And the project is obviously the same, but the features are going to be wildly different or wildly similar. And that's where the merging conflicts can happen. But the point is that the staging branch is used for every developer to then merge their feature branches into. And then that gets tested, as I mentioned. What you want to make sure is that the feature branches are constantly being rejuvenated by the main branch. So you want to be merging the main branch back into your feature branches and then merging your feature branches into your staging branch. You never want to merge staging into your feature branch because then you get everybody else's code. Don't do that. But when something is acceptable for launch, move that or merge that into your main branch. You could do that via a pull request or what have you. And then, so that will update the main branch. You then want to acknowledge when that happens, and then merge the main branch back into your feature branch, and therefore you're all constantly evolving your code and going forward. Nobody's getting stale. That's the point here. It's stale code is bad code. So you want to make sure at least once a day, if not 3 times a day, make sure that any changes in main go back into your feature branches, and then, by definition, they'll go into the staging once you merge that into staging. Okay, so yeah, regularly merge main into your feature branches. Number 7 is always get a teammate to review your code, even if it's the smallest change. So even if it's this like literally a single line or a comma or something out of place that you've fixed and changed, get someone else to review it. It's not a negative reflection on you. It's just that other developers may have other suggestions and other ideas, and also more eyes on the code is really good. I know that there's, just talking from experience here. I've done a piece of work, and then I've, really small piece of work, and I've asked someone to take a look at it, and then they've come up with a better solution, and I've ditched my attempt, and then I went with theirs, and it worked out pretty well. Like I said, it also shares knowledge across the team, and they'll be able to spot issues very, very quickly. Because the thing is, you get so close to the code, you get so close to it's like that saying, you can't see the wood through the trees. And also they may be aware of other elements of the code that impact or influence your bit of code that you are not aware of. Also, they may have other historical knowledge about the client, or they may have some future knowledge about the project that will influence and impact the thing that you're doing. So make sure that you do get your code reviewed. GitHub is great for that. You've also got Bitbucket and other things like that. GitLab for code reviews. Definitely do that. Get it approved by at least one developer, if not 2 if you can. And also, if you're a back-end developer and you're playing around with some JavaScript, get a JavaScript front-end developer to have a look. Get a front-end dev to have a look, because they will probably, it's happened to me, where you do some JavaScript, you're like, yeah, I've done some JavaScript today, because that's for me that's a bit of a rarity. Sometimes, and you give it to a JavaScript dev to have a look at, and they're like, "No, you don't. You don't want to be doing it like that. You want to be doing it like this, because if you do it like that, then you've just caused a performance bottleneck, or this is a quicker way of doing it, or there's some new JS syntax sugar that we could throw on this, or as it has happened to me before, they are aware of a browser compatibility issue that you're not aware of, and they go, it's a good job you showed me this, because this ain't going to work on version whatever of IE. So don't be afraid to give it to someone else to have a look at. In fact, most of the projects that I've worked on, actually, they require it to happen. You can't push any code into, definitely not the main branch, but in some cases, the staging branch, you cannot push code into there unless it's been looked at by at least one other developer. And there have been places where I've worked at where it's been at least 2 developers as well, around the skill set of the code that you're working within. Okay, will I be putting these steps into sort of a practical thing after the talk? Well, I guess some of these I do anyway whenever I do a live stream. So here I'm answering one of the comments here on the chat. It's a good question, but I do a lot of this stuff anyway on the YouTube streams and the Twitch streams. But maybe I should point out areas of when I do those kind of things, and because it's only me, so I won't do all of them, obviously. But maybe I will. Maybe when I get to doing like a pull request for myself, I will talk about it from the perspective of another team. It's a bit difficult doing this in practical steps when it's just me, if that makes sense. You read a load of these things, like tutorials for Git, and they've always got like Sally and Bob. Sally and Bob. Sally has this feature branch. Bob has this feature branch. Some other random name has wants to do a deployment. What are you going to do? So yeah, no, maybe I can stop whenever I get to a point where I think, actually a team of people would do this differently, and I could talk about it during a live stream perhaps. That would be pretty good. Okay, so where are we? Number 8. Number 8 is to keep good branch naming conventions. So I'm dyslexic. I spell every single word I could possibly type wrong. Like, I'm pretty sure I've spelled every word that I know wrong in my life. But make sure that you try and sort out the spelling, okay? Because this is going back to that historical thing as well. And also in terms of conventions, and there's ways of like, if you create a branch and you spell it wrong, there are ways to change the branch name through the command line. Then I'll show whenever I do it, and I will probably spell something wrong in the future. Same with Git commit messages. If you're reading back your commit message and you realize that you've got a spelling mistake, there is an amend argument that you can do to change the Git commit message. Can't talk. As well. But in terms of conventions, you want to make sure that you stick to like bug fixes, feature for a feature, and then maybe like config for configuration. Try not to have configure or features instead of feature. Try and have some form of convention around your branching. It's just easier when you're having to sift through historical branches and whatnot. And I suppose this goes on to the next point of, make sure that your branches locally are nice and tidy in the sense of don't have too many lying around. Whenever I finish a project, like whenever I leave the contract, I obviously need to do a load of tidy up on my local machine. So I try now, I never used to do this regularly. I used to do this once I left the project. But what I try and do now is go through all of my local branches and remove the ones that I'm not actually actively working on. It's just easier right at the end of the project. You can, of course, just delete the whole Git thing if you wanted to. But I try and do this periodically, and also try and delete the remote branches as well, because if you've got a project and you've got like 50 branches and they're all old and they're all behind the main, then there's no point in having them, right? Get rid. It's just easier to identify the ones that are actively you're working on. You don't have to use fancy labels or anything for the branches in GitHub. You can just see what's what. Okay, so where are we now? Number 9, separate code maintenance, features and fixes into their own branches. Be aware of what other features use your code. Yes. So this is going back a little bit to the configuration, but so where you would put config into its own branch. But I've gone one step further with this, and I'm talking about maintenance. And when I'm talking about maintenance, what I really mean is like refactoring, or if there's a problem that you've found in the code, whether it's a bug fix that needs to be done, or whether it's a piece of refactoring, you want to rename some variables or some classes or some methods or whatnot. Or maybe you just want to re-architect things. So this is kind of the gray area of, it's not really a fix because nothing is actually broken, and it's not a feature because nobody's requested it, but it needs to be maintained. As in, it needs to be, it's like going to the having your car MOT'd and finding that there's a couple of things that are wrong, but you can get away with them. They're minors, but you want to fix them anyway. You want to fix them up. So I would separate, if I was to start a project and I was to look at some code and I was to see the code, the existing code base, and I was to look at areas that I would like to tidy up and to refactor, then perhaps I would, in some circumstances, this doesn't happen all the time because time pressures and everything, but sometimes it's good to speak to another developer who is aware of the code base and discuss your ideas for refactoring, and then see if you can do those before you do the feature. It's going to make your feature a lot easier because it's going to be more snapped together. Plus, you've given it a more in-depth thought because of these refactoring things that you want to do. But put them in a separate branch. The reason why you want to put them in a separate branch is because if you've got a lot of refactoring to do in that particular feature that you're doing, that feature might be, that code might be used elsewhere. So if you're changing code that other code hooks into, and you're, say, changing method names or changing parameters and variables and all of that jazz, then you're going to impact someone else's feature or another area of code. And so you want to reduce the amount of negative impact as much as you possibly can. So don't bundle that all up, or try not to bundle all that up into a feature. The thing is, excuse me. The thing is, the difference between the refactoring branch, if you will, and the feature branch is that the refactoring branch doesn't have a time frame, whereas the feature branch does. A client has requested that feature to be developed. The client hasn't requested you to refactor that feature or that code for that feature. They're not aware of the code. They shouldn't be aware of the code. But you as a developer, you've looked at that code and you've gone, we can do something better here, or this isn't good practice. We need to adjust this and refactor this. It's going to make my life of building this feature a lot easier. It's going to make the lives of the other team, my teammates, easier as well, because the code will become easier to use. Perhaps there's a code smell somewhere. Perhaps there's an architectural issue that needs to be addressed. And so you think about, you're kind of thinking outside the box here. And then you speak to, say, your the technical lead, and you say, look, there's this piece of code that I really think we need to refactor. This is what I propose. Can I do this in a separate branch? Make the other team members aware of it, get it done, and then build out that feature. Do it like that if you can. It doesn't always happen like this, but if you can. The thing is, a code base is constantly evolving, and it shouldn't just evolve just because the client has requested new features. It also should evolve because new developers come on board and they see code smells, or old developers see code smells, and they're constantly trying to improve the system going forward. But the thing is, those micro improvements aren't necessarily tied to a single feature that the client has requested. Because, code is interwoven. So one thing can impact another thing or 10 other things. Okay. So let's talk about messaging platforms. So this is number 10. So a lot of what I've mentioned here is around communication, having the ability to communicate your code, your technical concerns about the code, and your ideas to the team. And the best way I've found to do that is through, say, Slack or Discord or Microsoft Teams, somewhere that you can share code snippets, somewhere that you can format code, and somewhere that people can
Hello,
access
coders.
links. Woo! That shocked me a bit. Thank you very much, Ashley Simmons, for subscribing. I was in the zone then. I didn't forgot that that happened. Thank you. You've just gone and set the emotes off. Woohoo! Thank you. Yeah, so have a messaging platform that that everybody can access and share, and make sure that this is automated as well. So whenever someone does a pull request, that is sent as a message to Slack. Whenever someone does a merge, that's also an automated message in Slack. Whenever the CI pipeline fails, that's also a message in Slack. So everyone is aware of the state of play of the pipeline and what code they're working on and what code other people are working on. So it's a really good way to have a sense check of the code base and how stable it is. Also in production, if you've got any errors coming, that you really need those coming into Slack or whatever messaging platform you use. Basically, make sure that it's properly seamless. And what I found is really good is to have a separate channel that is for automated messages that you can check on and stuff. And I guess number 11, we've kind of already mentioned this, but to fix any failed code audits before doing anything else. So if PHP Stan was to say, no, this isn't good, fix that first, because you've gone and produced a bottleneck in the pipeline. So make sure that is ironed out before you can. Thank you very much for joining, Ali. I appreciate that. Thank you very much. So yeah, they're my 10 sort of tidbits. I will quickly run down. So run code audits before merging work into a workflow branch. So run PHP Stan, linting tools, PHP unit, whatever you use, run all those before you actually put your code into staging or whatever. I do this regularly. Usually what happens is I will go and make a cup of tea, and then as it runs, and I come back and it'll tell me what I need to fix. But make sure you do this before you actually merge this into staging. Okay, put config into a separate branch, then the feature as well. Use a GUI to inspect the right, left, and middle merges. It's really, really useful to have a look at diffs like that. In my opinion, don't squash commits, because I really like to read the history. Communicate and talk through conflicts with other developers. Make sure that you can get access to other developers who have worked on the code that your code is conflicting with, so you can get multiple eyes on that. Regularly merge the main branch into your feature branches, so make sure that you don't have any stale branches working around. Always get a teammate to review your code, even if it's the smallest of changes. Keep to a good branch naming convention. So as we mentioned before, like feature over features and fixes over fix, maybe. I don't know, it's up to your team, but try and keep it to a convention. Separate code, maintenance, features, and fixes into their own branches. Be aware of other features that use your code. So this is where you look at some code and you're like, this needs to be refactored. Maybe there's a possibility of doing that refactoring work in a separate branch before building out the feature, because the quicker you can get this to into the main branch, the quicker other developers can use this good piece of refactoring as well. It's all about teamwork. Okay, use messaging platforms like Slack or Discord to inform your team that something has been merged. Also, use this to tell your team if the code audits have failed, if your pipeline is buggered. And if it is, fix it before you do anything else. Thank you ever so much for watching. That's episode 119. I appreciate everybody's questions and comments in the chat. I'll review them, and I'll think about doing the practical video or doing that within another live stream, I think, perhaps going forward. But it'll be an interesting one. I will be streaming again this Saturday on Twitch. I'll let everybody know the times of that from Discord and on Twitter. I've forgotten Twitter at How to Code Well. So thank you ever so much for watching. Happy coding, everyone. Have a great evening, and I'll see you again soon. Cheers. Bye-bye.